LIGO, this laser interferometer gravitational wave observatory, gravitational waves, it took headlines a few years ago when it detected the first ripples in the fabric of space. It detected them from two black holes that were 1.4 billion light years away, like 1.4 billion years ago, rotating around each other, going near the speed of light, slamming into each other, creating a tidal wave in the fabric of space that rippled outward at the speed of light. Part of it raced toward planet Earth. There wasn't anybody on planet Earth to see it at that moment, but it had 1.4 billion year journey to traverse. It raced toward planet Earth. When it's about 100,000 light years away, it grazes the Milky Way galaxy. It continues to race toward Earth. When it's 100 light years away, a guy named Albert Einstein writes down equations that suggest there could be these gravitational waves, unknown that one is already racing toward the planet, right? And it continues to race onward. 2 light days. It's 2 light days away when they turn on the newly refined version of the LIGO detector. And 2 days later, that wave rolls by planet Earth, shakes the 2 detectors, one in Louisiana, the other in Washington State, giving us the first direct detection of ripples in the fabric of space and establishing that the story that I told you is true.
Wow.
So these things are real. They're out there.
That is wild.
And before the direct radio telescopic imagery from the Event Horizon Telescope of the black hole in M87, that ripple in the fabric of space was the most direct evidence that black holes are real, because when you took the way that the machine in Louisiana and Washington, it twitched for just a tiny fraction of a second, when you figured out using supercomputers what the cause of the wave must have been, you are led to 2 black holes that are 28 and 31 times the mass of the sun, or 36 times the mass of the sun, numbers of that sort, and that was the only explanation for the data. And so there's this beautiful indirect proof that these stellar-sized black holes are actually out there. And then, of course, we take a photograph of one in a nearby galaxy.